Okie doke, tell me one.
29.
29. Tell me how you rewrote it.
I did secant to the fourth tangent, or secant to the fourth 4x, tangent 4x, and then I kept the secant squared as like, this is going to be the derivative of it.
Well, that's not the first thing that crosses my mind, but I wonder if there's just a different way to do it, and if so, where you made your mistake. I'm going to try your way, and if we can't make it work out that way, then I'm going to show you what I did. My first instinct was, if I have both secants and tangents, and I can just pull out one secant tangent, then what I'm going to be left with is a power of secant. But I still am interested in where you might have gone wrong. Cheryl, were you going to say something? Tell me what you were thinking. That's what I did. Yeah. So that you had a secant tangent beside it. Now, Sam, if you said secant to the fourth, I'm going to say secant 4x to the fourth power, and then you would have a tangent 4x and a secant squared 4x. That's what you did, Miss Sam? Okay, and then what?
And I changed the secant 4x to the fourth to 1 plus tangent squared 4x squared.
You said secant squared is 1 plus... Oh! You would have to say... In order to do that, you would have to say this is secant squared squared, and then the secant squared is 1 plus tangent squared, and then you would have to FOIL that out. You did? Mm-hmm. Oh, okay. All right. So tangent 4x, and you didn't make any other substitutions at this point? Multiplied that out and got 1 plus 2 tangent squared 4x plus tangent to the fourth 4x. Even if we can get this to work, I can tell you it's a lot harder than the other way. And then tangent 4x secant squared 4x dx.
I looked at this sheet and it said, like, if the power of secant was even, and you had secant and tangent, to convert it all to tangent. So I just went ahead and did what the paper said.
Yeah, I'm trying to get weaned off that paper, and I'm getting pretty good at thinking, if I have both secants and tangents, and I can get a secant tangent out of it, then I'll just leave secant to whatever power. But so far, did we have the same thing?
Yes, we did.
And Miss Emma was saying Sam tried this a different way, and I didn't do what she did, but we're looking to see if what she did would work. And then, yes, that's 29. And then what, Sam?
And then I distributed the tangent and secant squared to everything.
Okay. I haven't found a mistake yet. It's just making me cringe. No, it's okay. No, you followed what the paper told you. Plus 2 tangents cubed secant squared x. tangent to the fifth 4x secant squared 4x dx. Okay. Second term, 2 tangent cubed 4x secant squared 4x. Everything else right? Okay. I think your answer is going to be equivalent to theirs, because now every one of those has a secant squared, and you can use the power rule on all the tangents. Yes? So this first term would be 1/2 tangent squared 4x, and the next term is going to be 1/2 tangent to the fourth 4x, and the last term is going to be 1/6 tangent to the sixth 4x. And I was going to double check, but if you found something before I did. Yes. You have to have, you have to accommodate for the fact that the argument is 4x, so you have to have a 4 here and a 1/4 there. And if I distributed my 1/4, would I have what you have?
Yes.
Okay. That is fine. Yeah, and they somehow changed all those even powers of tangent back to secant, because let me show you how easy it would have been otherwise. Are you prepared? I don't want to make you cry, but I'm fixing to.
Yeah, it's going to be 3 lines.
2.
Yeah. When I was
It is.
okay, I was freaking out because like I had done the wrong problems, and while they were doing that, I scribbled out, pointing out. I was like, I'm already done. Why are they still going? What did I do wrong?
I love that Samantha's way worked. Yeah, you didn't do anything illegal. You got a different looking answer, a very difficult way, but I have to give you 100% correct on the test.
Hey.
Wow.
Okay, good.
Okay, what else?
25.
25. Now that one,
I think I did do something wrong with this one.
okay. Let me see if you started it the same way I did. Tell me what you did.
I put it as tangent square x over 2 square times tangent x over 2.
Don't you have a -1 in there? Tangent. You broke it into tangent squared times tangent cubed? Yes? No? Tell me again what you did. Just leave out the argument. Just give me the...
Tangent to the fourth times tangent. And then I took the fourth and made it tangent squared to squared.
Okay, that's different than what I did, so let me look at it again. You're saying tangent to the fourth times tangent and then you wrote tangent to the fourth as tangent squared, secant squared -1. You didn't have your -1?
I haven't changed it to secant yet.
Oh, okay. So secant squared -1 squared times tangent x over 2 dx. So that's what you had on the next line, and I was misunderstanding where you didn't have a 1.
Yes.
And then you fold that out. I bet you got an equivalent answer then. And at first glance, this is not looking as difficult as what I did. But let's see. That would be secant to the fourth minus 2 secant squared plus 1 times tangent x over 2 dx. So far? And then I assume you distributed tangent? Okay, and maybe,
And then I put secants, and then secant over. And then we'll also do this too.
I'm trying to figure out where your secant tangent came from. Because that last term's not going to have a secant tangent.
Yeah, it's just going to be tangent, but then I made it sine over cosine, and I made
Okay.
it a natural log.
Okay, okay, that would work. So, I'm going to write it as 3 integrals now. You have secant to the 4th x over, secant cubed x over 2 times secant tangent. And in order to integrate that, you'd have to have a 1 over 2 with a 2 out here. So that's what you had for your first integral, right?
Mm-hmm.
And then your second one, you would have 2 here, and say secant squared is just secant to the first times secant tangent. And to differentiate it, this is going to get tiny. To differentiate it, I'm going to have a half dx. And if I have a half there, I got to put another 2 dots here. I'm just going to go ahead and call that 4. And then the last term is going to be plus the integral of tangent x over 2 times 1/2 dx times 2. That's the only one that has a minus.
I put it as minus the integral of tangent.
Instead of
First,
plus.
just accidentally.
Okay.
That shouldn't change all of that.
No, that shouldn't. You have secant, if you have ugly squared with the derivative of the ugly right beside it, there needs to be a little dx in there. So I can use the quotient rule, or power rule. I can add 1 to the exponent and divide by the exponent. And the second, you have minus 4, and then you have secant ugly, or you have ugly to the first and the derivative of the ugly. So the antiderivative of ugly to the first is ugly squared divided by 2. And then the last 2, and the antiderivative of tangent. If you remember it, yay. If you don't remember it, write it exactly like you did. Tangent is sine over cosine, and since sine is almost the derivative of cosine, except for you need a negative, this would become minus 2 natural log of absolute value of cosine of it. And clean that up and that up, and you have what you have.
Yeah.
And that's not the answer in the back of the book. It's just a different equivalent. I'm telling you, grading calculus test is a pain in the patootie, because you can get a completely different looking answer. Now, I'm going to say on this one, my way was about as ugly. What I did was break it into tangent squared times tangent cubed, and then wrote my tangent squared as secant squared minus 1, and went from there. Miss Cheryl, do we need to look at one of the ones that was bugging you? Any, mini, miny, mo, pick one. 33. Okay. let's just see how you got started. And if you did it differently than I did, we'll try it your way. Tell me what you thought.
I really like
Okay, so sine squared over cosine squared times cosine over 1. And that is sine squared cosine, no, sine squared over cosine. Well, this is different than what I did, but we'll see if we can get it to work. I'm worried about Miss Michaela. Is anybody? Okay, so let's see. I don't know if I can do anything with that or not. What do you think? The derivative of cosine isn't sine squared. The derivative of sine squared. Really?
No, I had an example saying it was similar. It wasn't the same.
Oh, okay. You're not saying look at CalChat. You're just saying one example in the book.
Yeah, did you take sine squared and make it 1 minus cosine squared and then square root the 2 fractions?
Yeah, and I think that will basically be the equivalent of what I did. Secant squared minus 1, and then make it 2 fractions. I think this is going to work, Cheryl. Sine squared is 1 minus cosine squared. And then if you break it into 2 fractions, that is 1 over cosine is secant, and cosine squared over cosine is just cosine. So far? And what's the antiderivative of secant x? I would have to write down what I think and then check it. I don't think it has a negative. My gut says no negative. Plus. Yeah. And again, I'd have to check it. But, let's see. The antiderivative of cosine would be sine, so this should still be negative. Yep. And what I did differently, Cheryl, would have ended up being the same thing because secant, tangent squared is secant squared minus 1. And when you break that into 2 terms, it's still secant minus cosine. All right, let's talk about the new stuff, which isn't really all that bad. We may even have the time to go back and do another question from the homework if you need it. But something else I'm going to give you on the test. Oh, I just could not handle memorizing that. The product to sum identities. And both of them have the argument of the first factor being m and the argument of the second factor being n. So if you encounter a problem that's sine, or sine, cosine, or cosine, cosine, then you'll have those at the top of the test. You just pull off the m and the n and substitute it into that formula. Yeah. Now that just changes one expression into another expression. It doesn't integrate it, but it often gives you something that's easy to integrate. Number number 43 through 47 in the homework use these formulas, and they are pretty fast. So let me show you one. Number, what do I have circled? Number 44. You just call that cosine 8 theta and you're done with it? That's highly illegal. That's highly illegal. Theta squared then. Cosine 15 theta squared. That would be good. Okay, so that's two highly illegal things. And nothing that I know so far lets me integrate the product of two trig functions with different arguments. We just don't have anything like that. But then I remember I have some product to sum identities, and that's important because I can't integrate, product means multiplication, I can't integrate factor by factor, but I can integrate term by term. That's why if we can change a product to a sum, it'll be easier to differentiate. If I look at this as being formulas A, B, and C, then that one has cosine, cosine. It's formula C, with M being what? M is the coefficient of the argument of the first cosine. That's your M. Okay. That's your M, and then your N is the coefficient of the argument in the second cosine. So 5 is M, 3 is N. Yes? Gosh darn it. You know, I knew I had a typo last year, and I couldn't find what was looking, or I couldn't find it. Yes. My eyes just cross when I see that new parentheses. And yeah, that 1/2 applies to the whole thing. Yes. So then I need to fix that. Parentheses, parentheses. I swear I can't look at it and see. Let's see. I have parentheses, brackets, parentheses, brackets.
The first one has the closing parentheses, but sine, cosine, and cosine, cosine don't.
I can't even see. My eyes literally cross when I look at it. I'll look at it again. I can't. Okay, so yes, let's say, I don't know if this will fix it or not. I need to look at it more closely again, but I looked at it closely before I handed it to you, and I can't count my parentheses and brackets. All right, so it's formula C. 1/2. I'm just going to bring the 1/2 out in front of the integral, and then integrate cosine of M minus N would be what? Mm-hmm. 2 theta. Plus cosine of what's N plus N? 8 theta. Now that we've changed that product to a sum, look how easy that is. If we integrate cosine 2 theta, what do we have to have beside it? A 2b theta. And if I need a 2b theta, then I need to put a 1/2 in front of the integral. And then to integrate degree. Cosine 8 theta, I would have to have an 8 d theta beside it. So I need a 1/8 in front of that integral to make it equivalent to the line above it. Double check that what we have is equivalent to the line above it, and in the form cosine ugly derivative of the ugly. It's not. What have I done wrong? But this is why I'm checking myself. Yes. Yeah. I just need cosine 2 theta times 2 d theta, cosine 8 theta times 8 d theta. And what's the antiderivative of cosine ugly with the derivative of the ugly right beside it? Right here. What did you say? Oh, there we go. Sine 2 theta. And I double check when I differentiate sine, I do get positive cosine, so that's right. And here, I'm going to multiply that half times an 8 is a 16th. And the derivative, antiderivative of cosine 8 theta is sine 8 theta. Factor out a 1/16 if you want to. Plus C, minus 10. Yep, that formula makes it much easier. I wonder if you even need to see another one. 46 and 48 are the same thing. Once you, on 46, are you going to use formula A, B, or C if you have sine, cosine? Yep. Sine, cosine is formula B, and so 46M would be what? 8, and N would be 7, and you just plug it into the formula. Which formula would you use on number 48 with a sine, sine? That's formula A, where M is 5 and N is 4. All right. Give me 20 of those on the test. And the only thing that is yuckier about 59 to 66 is after you do the anti-differentiation, because those are definite integrals, you have to evaluate them. Let me see if one of those is particularly sticky. Let's do 62 just for the heck of it. And then if you have more homework questions, we'll go back to them. No, there will be a couple on the test that say find the exact value. Anything that doesn't say find the exact value, even if I forget to type in the directions, if it doesn't say find the exact value and you use your calculator, I'll count it right. But if it does say find the exact value and you give me a decimal approximation, that would probably be no credit because it's kind of a no-brainer without. It will change an irrational number? No, it won't change an irrational number. Okay, tell me what you're thinking you need to pull out of that. Yeah, I'm thinking I'm going to need a secant tangent at the end, and then at the beginning I'll just have secant to a power. So, secant x to the 1/2 times secant x tangent x dx. Before I go any further, is that equivalent to the line above it? Yes. And do I have secant to a power with the derivative of secant right beside it? Yeah. This is just going to be a little bit ugly to evaluate. I am anti-differentiating. Ugly to the 1/2 is what? Two-thirds ugly to the 3/2 evaluated from 0 to pi over 3. And so pi over 3, believe it or not, if you ask me to find C, I go pi over 3 is right here, where x is 1/2 and y is square root of 3 over 2. Okay, I'm going to just keep that 2/3 outside brackets and say secant of pi over 3 is 2, and so I have 2 to the 3/2. And then secant 0, the radians is right here. Secant 0 is what? 1, and 1 to the 3/2 is just what? Just 1. But maybe all I can do, since I can't take the square root of 2 and leave it as, without changing it to an irrational number, without changing it to a decimal number. So 2 to the 3/2 minus 1. That's C. Nope, that's C, because this is definitely integer. They wrote that as 2 square root of 2. How did they write it? Oh, I see. Because that is, this is 100% okay, but I could also write that as the square root of 2 cubed, or the square root of 8. And the square root of 8 is 2 square root of 2. So it doesn't matter which one of those ways you write it. Man, you've never had extra time to do some more homework problems. Yay! Yay, I'm thankful for that, man. You needed a better day. From the same section, right? Yes, integration by parts. That's the one you remember to look at example 5, right?
Yeah.
Okay, and it still got nasty. And Miss Cheryl, was it 13 or 23 you emailed me about last night? Okay, but you remembered to look at example 5, integration by parts. Okay, well, let's see it then. None 23. That example 5 applied whenever we had an odd power of secant. See example 2. Example 5, blah, blah, blah. So, 23. Secant 2 pi x. Yes. I'm already wanting to write this as 1 over pi times secant cube pi x times pi dx. And then I'll break apart the secant cube however I have to, but I've taken care of this is secant ugly, and that's the derivative ugly, and that makes it equivalent to the line above it. So, don't have to deal with that anymore. Now, according to example 5, when you have an odd power of secant, how do you break it apart? Okay, so I'm going to let that be. But that was the example 5 in the book.
Mine says power of secret is even possible.
Oh, shoot. Okay, what's bugging me? What's bugging me? Yes. Hey, I'm not sure. I'm confused. Right here, this number 4 says when secant to the power of x dx, when the exponent is odd and positive. Use integration by parts.
Okay, so I guess it would be different. Because mine is only 5 since power of secret is 3.
Oh, they have a different. They have a different example 5. Oh, I didn't check to see that they hadn't changed the examples in the book. Well, that's not good. Somewhere, I need to make myself a note to check that. Because example 5 in the old edition was secant cubed. Whoa. I'm going to show you this thing.
Mine's fine. And then you might exhibit 5 and 8.2 or 8.3.
Oh. Yes. I did say example 5 in section 8.2.
Okay. That one's secant cube.
Okay. Because that's where they first integrated secant to an odd power. They're just reminding you we did this in 8.2 by parts. And so this is example 5 from 8.2. We break the secant cube into secant squared times secant, and then let u be secant and let dv be secant squared, because I can take the derivative of secant and I can integrate secant squared. All right, so let's try that. I'm going to keep that 1 over pi out of the way the whole time and say this is secant pi x times secant squared pi x times pi dx. So far, so good. Okay. If I let u be secant pi x, I can differentiate that. And that means dv has to be everything else. dv is the secant squared pi x pi dx. I just wonder now if that's going to mess anything up that I stick that out to begin with. I'll think about that just a second. The derivative of u is the derivative of secant pi x, which is secant pi x tangent pi x times pi. So far, so good. What about the antiderivative of secant squared pi x pi dx? What is that? Do I need to put a 1 over pi out front or something? No, because I did it. Yes. So that's just tangent squared pi x. All right. Integration by parts. says, keep up with that guy, and the integral of u times v is u dv is u times u times v would be secant pi x tangent squared pi x minus the integral of v should not. I was saying v du. How in the world did that help? What about what we left with here? Oh, I didn't fix this tangent. That is u times v minus the integral of v du. Now, how do I integrate that? Okay, you got just a little bit ahead of me. One thing at a time. No, you can. I can't. I'm going to multiply the two tangents. I brought the pi out front. Actually, I'm not going to because I'll need it with the dx in order to integrate. So I'm not going to do that. I'm just going to say that's tangent squared pi x times secant pi x times, I'm leaving that pi right there, pi dx. So far, so good. And then I would need to do what? Let me think. I was thinking tangent times secant tangent, but that's no good. Yeah, that's no good. Not quite sure. So far, so good. Yes, ma'am? I almost wrote it down so I could look at it because I don't manipulate things in my head. 1 plus tangent squared equals secant squared means tangent squared is secant squared minus 1. Dang it. I just need to write it down. I'm going to try to get cocky and not write it down. I cannot solve equations in my head. Secant squared pi x minus 1. Then what? You see, last night's homework was way harder than tonight's. So that would be secant cubed pi x minus secant pi x. Oh, holy cow. Holy cow. That's fixing to happen again. Okay, let me keep going. Secant pi x. Wow. That's okay. I barely do. Before we say what's coming next, is there any question about what we have so far? No. But I am going to need to bring down the left-hand side of my equation. I really wish that I had not brought that one up out of 1 over pi out to begin with, because it's fixing to cause a problem. I can fix it though. See all of that? Let's see that. Now distributed down over pi. And we'll break that into 2 integrals.
Can you just take the 1 over pi and put it back in there so that you can add?
Well, I can add it anyway. This coefficient is 1. This coefficient's 1 over pi. So if I added this to both sides, what would I have as a coefficient?
You need to do that because you could apply it in your integral on this side to not on this side.
Oh, okay.
You have to make that one.
Yep. I thought I was making things easier up here by taking out that 1 over pi to begin with, but I did not make things easier, which means you've written a whole lot of stuff that you would have to mark out. Dang it.
You do it at home because I have other questions.
Yes. Let me show you what it would look like if I had not factored out that 1 over pi to begin with. This is where we did one problem like this in the homework, where we had a secant cubed pi x on both sides of the equation, and we added secant cubed pi x to both sides of the equation and ended up with 2 secant cubed pi x. We could integrate everything else and then divide everything by that 2. Yeah. So if y'all want to look at that one again, now that you know it's 8.2, Miss Emma, I bet you can get it. Tell me your other one, Miss Cheryl. Number 11. At this point, I'm praying for easy. There is something that I automatically think when I see sine square or cosine square. Where do my eyes go? Yes, I gave you 2 formulas that come in helpful when you have sine to an even or cosine to an even, and I told you I'd give you these on the test. So let's take that cosine square and just change it with this formula. Cosine square is, if this is my u, then the formula says cosine square u is 1 plus cosine 2u over 2. And that's just bio formula I'll give you on the test. Alright, tell me what you thought next, Michelle. Okay. Into 1/2 plus 1/2. You could either separate them or you could just bring 1/2 out front. Since that denominator is a monomial, what you said would be equivalent to just saying that's 1/2 times 1 plus cosine 6x dx. Makes it just a little bit easier. If you don't factor out either, you can factor 1/2 out at the end. I'm going to break this into two integrals and say it's just the integral of dx. Isn't that weird? To see absolutely nothing in the integram but dx? Okay, put a 1 dx then. Plus the integral of cosine 6x. If I'm going to integrate cosine 6x, what do I have to have beside it? 6 dx. And what do I have to have in front of the integral to make that equivalent to the line above it? 1/6. What's the integral of 1 dx? Just x. And what's the integral of cosine ugly if you have d ugly right beside it? Sine ugly. And then I'll check my SIGN. Correct. I'll check my SIGN. When I take the derivative of sine, I get positive cosine. That's what I have. So that's correct. And then plus a C. And that's 100% okay. If that's not the answer in the back of the book, what have they probably done? Probably not. Although that would be okay. I think they've probably factored out a 1/6. You're not going to get any points off, Miss Bitter. Man, if I had my crybabies in here. I see my crybabies under the cabinet. I haven't thrown one at my pre-calculus class yet, but I know they're down there just waiting on Davis to reappear. No points off if you stop right here. I am tickled to death. All right. Probably have time for one more if anybody has one. Okay. Number 9 is the integral of cosines. Wait, that's what I have for number 11. This was 6 points. Other addition. This number 9. Ooh, yeah. See you, Sam. This was sine cube 2 theta times the square root of cosine 2 theta d theta. Tell me what you think. Okay. So sine square 2 theta times cosine 2 theta to the 1/2. And then my other sine 2 theta. and then my d theta. Only since all of those have arguments of 2 theta, to differentiate, anti-differentiate any of them, I'm going to have 2 d theta, so I'm going to put the 1/2 out front. So far, that's what you do? Okay. And then, the purpose of doing that was to change this all to cosines,
Yes.
because the derivative of cosine would be this sitting right beside it. So, sine square is 1 minus cosine square the substitution right there, and then distribute this. Cosine to the 1/2 2 theta minus cosine to the, I think I'd rather write it as cosine 2 theta to the 1/2. Minus cosine 2 theta to the 5/2 with sine 2 theta to d theta beside it. Is that what you had so far, Michelle? Okay. I can integrate both of those by the power rule. This is ugly to the 1/2. This is the derivative of ugly. This is ugly to the 5/2 derivative of ugly. So what is the antiderivative of ugly to the 1/2? 2/3 ugly to the 3/2. And what's the antiderivative of ugly to the 5/2? Everyone cleaning up fractions? Is that a finished one? You see where you lost your sign? Let me see. They have -1. Yeah.
I guess I never.
Something's bothering me. Oh, snap. No. I see why. If I let u be cosine 2 theta, what's the derivative of cosine 2 theta? Yeah. The derivative of cosine is negative sine. So if I'm going to integrate this as ugly to the 1/2, I have to have the derivative of the ugly beside it, which means I have to have -1/2 out front. Yeah. And this is in parentheses. So negative sine, -1/2, that, and then if you distribute the -1/2, you have -1/3 cosine 3/2 2 theta plus 1/7 cosine 7/2 2 theta. Let's see.
I was like, let's see where there's a square root on my board.
Okay. All right, so whatever you haven't finished of 8.3, just finish it tonight, and I will either take it up or I will have you wave it at me. I may just have you wave it at me. that last test grade may just turn out to be an attendance grade.